Just the last few words to finish off. We can talk about some terminology. Some of you may be familiar with this, others not. So let's, there's some confusion about this when it comes to accuracy, quality, accuracy, precision, and then a term that is quite useful to introduce is trueness. Depending on which definition of these words you find, accuracy, precision is always, pretty much always the same thing. Accuracy is sometimes more inclusive. Accuracy and trueness sometimes overlap, depending on which definition you're looking at. Some of them don't have trueness at all, and everything is baked into accuracy. Others combine these. So precision, good enough. If we look on this grid of images here, good precision in both of these. We can see that the cluster of points, statistical data, some people liken this to shots at a target or what have you. We can see they're all clustering quite nicely. There's a high precision, but if this is the true value or the target, or whichever, however you want to visualize this or think of this, we can see that it's missed. It's way off, even though all of our measurements were tightly packed and we didn't have much error in our measurement. Even though we had that, we still managed to miss the actual true value that we were after. So we had good precision in both cases. Here we have poor precision. We've got a broad spread. Our measurements are, they're not terribly precise. There's some noise, some kind of random noise coming in there, in terms of the shooting on target, wandering around all over the place. But in this case, on average, it's working out that you end up kind of hitting the middle. You're on target. That's not too bad. Whereas here, you're all over the place, and on average, you've missed it. You might have, you could actually end up with one measurement hitting it exactly spot on, but because you're considering the sum of all of these, it's not looking good. You're off target. So this can be quite difficult to deal with. This is wrong in many ways. This suggests some sort of systematic error. You're missing things, you're getting a precise measurement, something has shifted everything over. If you can work out what it is that's shifting that over, you've dealt with the problem. With this big spread, that can be difficult. That can be part of the system. What you're using to measure with just will not give you the precision you need. It may be impossible to get this nice clustering, and you just have to take more and more points and hope that your confidence in the average will improve, and you'll end up with the right data. And so trueness is, so we can say this has got good trueness here. This particular one, the trueness of these is poor. Both of these have got poor trueness. That's got poor trueness as well because it's not actually on the thing. So this is the only one that's got good trueness because it is precise and accurate. This, in some circumstances, is considered to be accurate because our average ends up on this spot, on the right place, but the precision is poor. Again, depending on who you speak to, which standards you're using, this can vary. This combination into trueness might not even exist. And then when we look at these, we can see that the clustering of our measurements, the distance, if they're tightly clustered, then we don't get a large spread, and that will influence as well our measurement, the resolution of our measurement. How well can we pick up a detail? How well can we measure something? That's a quick summary of the data accuracy and data in terms of measurements and what we can expect, or statistics as well. This applies to statistics. But when we look at quality as such, here again we have this sort of sliding scale. Is it appropriate? The quality of the data you've only got high quality data when it's used appropriately for the correct purpose, at the right scale, in the right place. So its quality is not, there's no such thing as a sort of independent determination of quality. It is always a matter of usage. Some things can be just generally poor because if we go back to this image, we're over here, we don't know what we've got. It's just basically some random noise that happens to be somewhere near what we think we're interested in. So that's, there's not much saving that. But if we have some fairly good data, for example, if we go back to this could be this data just zoomed in, for example. So when we're standing far away, well, that's good enough. Our precision there is good, and we're on target, so that's good enough for us. But then when we stand much closer and perhaps we have a higher demand on the precision, well, the same data is no longer good enough. We've got this spread. So it depends on context, and it's up to us to make that call. We have to understand the problems. We have to understand the limitations. It's your job. I think we can finish there.